In this video, we are going to prove the consecutive interiors angle and the alternate exterior angles theorem. So what the consecutive interiors angles theorem, or T8 in our case, states is that if two parallel lines are intersected by a transversal, again, using the picture from the last video, x and y are parallel lines intersected by the transversal z, then each pair of consecutive interior angles is supplementary. So that means that C and E are supplementary and D and F are supplementary. And I'm using SUPP as an abbreviation for supplementary. So angle C and angle E are supplementary, and angle D and angle F are supplementary. Let's go ahead and prove this with a paragraph proof. Line X and line Y are parallel and are intersected by a transversal Z, and that's based on what is given. By the definition of a linear pair, angle A and angle C form a linear pair, as well as angle B and angle D also form a linear pair. And we know that if two angles are a linear pair, by the linear pair theorem, those angles are supplementary. So angle A and angle C are supplementary, as well as angle B and angle D, by the linear pair theorem. So if A and C are supplementary, and B and D are supplementary, we have to figure out how to get to angle C being supplementary with angle E, and angle D being supplementary with angle F. And we can do that using the corresponding angles postulate. So by the corresponding angles postulate, we have that angle A is congruent to angle E, and angle B is congruent to angle F. So using substitution, we can just substitute E in for A and angle F in for angle B. Therefore, we have that angle C and angle E are supplementary, as well as angle D and angle F are supplementary, and that's by substitution. Because if we were to substitute E in for A, we have that angle E and angle C are supplementary, and if we were to substitute angle F in for B, we have that angle F and angle D are supplementary. And that is what we needed to prove, that if given two parallel lines that are intersected by a transversal, then each pair of consecutive interior angles is supplementary. The alternate exterior angles theorem, or T9 in our case, states that if two parallel lines are intersected by a transversal, then each pair of alternate exterior angles is congruent. So what this is saying, it's saying that angle A is congruent to angle H because they're alternate exterior, and angle B is congruent to angle G. Let's go ahead and do a formal proof to prove the alternate exterior angles theorem. Right away, we can say that X and Y are two parallel lines, and Z is a transversal of those parallel lines, and that's given. And using the vertical angle theorem, we could say that angle A and angle D are vertical angles, and angle B and angle C are vertical angles. Therefore, A and D are congruent, and B and C are congruent. So in proving this, it's all about using the angles and manipulating them until you get the desired result. So we need to get that angle A is congruent to angle H, and angle B is congruent to angle G. We started off by saying angle A is congruent to angle D, and angle B is congruent to angle C. So we need to find how we're going to relate angle A to H. And we know that angle D can be related to angle H because they're corresponding angles. And C can be related to G because they're corresponding angles. And since they're corresponding angles, by the corresponding angle postulate, angle D is congruent to angle H, and angle C is congruent to angle G. Looking at this, we have angle A is congruent to D, angle D is congruent to the angle H, so we can say angle A is congruent to angle H. Angle B is congruent to angle C is congruent to angle G, so angle B is congruent to angle G, and that's by the transitive property. And that's what we needed to prove, that if two parallel lines are intersected by a transversal, then each pair of alternate exterior angles is congruent. Angle A is congruent to angle H, and angle B is congruent to angle G. The alternate exterior angles.